I hope, is it visible to you?
Yes.
So, so we are geared up to start, am I right? Or we should wait for... Sure.
So we can wait for 1 or 2 minutes more.
Sure.
And then we can start.
Sure. Yeah.
Dr. Balaji, we may start, please.
Sure. Okay. Thank you. So good afternoon to all of you. I hope I'm audible, and please feel free. This is going to be the first. We'd like to start with the basics of DNS, and then we'll get into the abuse of DNS and what is happening in the country will be discussed. So let me start without further much of ado to this. So what happens behind the scenes when you just type a domain name or the URL in the URL address bar of your browser? Say, for example, I have taken an example of coednssecurity.in, which is basically our website, our project website. So when you type this coednssecurity.in in your browser, it has to, the browser actually is calls up the protocols, which is there for HTTP. And then, of course, it adds HTTP being a web page, so HTTP. And then there is the entire stack of protocols out there in your system. So what happens is your application layer, we call it as layer by layer. Of course, I hope you will all be understanding. So application layer, basically what happens is it sends communication to the transport layer, which is in TCP, and it constructs a TCP segment. And then the TCP segment actually have to contact with the network layer. The network layer where the router is there. And then further it takes communication with does communication with the data link layer. And below this, you have the physical wire and medium. So now, as you can see in this example, as you type coednssecurity.in, your connection has to be established from your browser to the server which is running this website, which is containing this program coednssecurity.in, that actually the connection has to be established. So how the connection is established? Obviously, it has to, your application creates TCP segments, and after that, it has to communicate with the router. And for that, while communicating with the router, as you can see, let me go step by step here. So once you type, let us say if you're typing HTTPS, ours is HTTPS coednssecurity.in, if you're typing, the transport layer has to specify the port from which it is. That is, your browser will tell which port it is actually communicating from. And then the destination, basically when I mean to say port is nothing but a landing point. That's all. So you can imagine as a landing point. So in the server machine, the landing point for HTTP traffic is 80, and the landing point for HTTPS is 443. Okay, so anything which you type as https://coe/dnssecurity.in, it lands in the port number 443. So this is by default actually. So the destination ports are default. The source code port can be anything from your machine. Okay, I think we'll come to the questions in a moment of time. If it is any audio issues, please let me know. Okay. Then what happens further is you go down to the network layer, and network layer you need to tell or find out the IP address of the machine which is containing this coe/dnssecurity.in website. So this is basically your IP. 202.141 is basically the IP from which you are communicating. That is, your browser is communicating to coe/dnssecurity.in. Now the issue is you have to find the IP address of the machine which is containing this one. Okay, so this particular question can be answered only by the DNS server. Okay, the fundamental, the entire part of DNS is to find an answer for what is the IP address of coe/dnssecurity.in. That is the main job of it. Okay, so unless otherwise you get an answer, you will not be able to establish a connection to this particular system, and then only you'll be able to get it. Of course, then further you need to find out the MAC addresses, that is destination MAC address and things like that. And then you get connection to the wire and things like that. So this is basically the flow which happens. So in total, the main point here is to translate a domain name to an IP address. That's the entire thing. Okay, the DNS, that is domain name service, translates the IP address to a translates the domain name to an IP address, and of course it can do the vice versa also. Okay, so let me just show you this one. www.cdac.in actually gets translated to an IP address like this. This is IPv4 address, and this is an IPv6 address. Whatever you're seeing below, 2405:8800 is basically IPv6 address. Now, you can do a reverse translation also possible. That is, from a given an IP address, you should be able to have the backward translation to cdac.in. And similarly, from here, you can see that if you IPv6 address, if it is given in the reverse way, you'll be able to find out the IP address, for the domain name of the given address also. So this is also possible. So DNS is basically a translation service which translates a given domain name to an IP address and an IP address to a domain name. So that is what is happening. So now let us see how to read a URL. So this is a very fundamental thing. You should always read a URL not from left to right, but you should always read from right to left. Okay. So for example, let us take this URL https://coe/dnssecurity.in. You should always start looking at the URL from the right-hand side of it. Okay. So, but before I tell you, you just need to always imagine a dot is there at the endpoint. Okay. You should always imagine there is a dot at the endpoint. And what you can think about is basically, say for example, if there is a dot at the endpoint and this dot actually refers to the root. Okay, this dot refers to the root DNS server, and this refers to a top level domain, that is .in. The .in actually refers to the top level domain, and coe/dnssecurity.in refers to the second level domain. So this is the organization of a URL. So when you look at any domain name, you should always read from the right to left. The right, always imagine that there is a dot at the end. Of course, this will be helpful for understanding later concepts. Okay, so this dot actually signifies the root, and this int signifies the top level domain, and coe/dnssecurity.in refers to the second level domain. Okay, of course, there can be further additions here. Whatever, if you want training.coe/dnssecurity.in or tools.security.in, all those things can be there, but there will be further third level domains. Third level subdomains are the given domain. Okay, so what this means is this creates a hierarchy here. What you can see is here basically dot is the root, in is basically below the root, and coe/dnssecurity is below the in domain. And further, if you want to add anything, it will come below coe/dnssecurity. Okay, so when I am saying in, this is basically refers to country, or country India. And this is a country level top level domain, CCTLDVC. So this is how the structure of a DNS system is there. So for example, when you look at coadnssecurity.in, as I said that you should imagine as there is a dot at the right hand corner. So here basically, sorry, from the dot you can see that the next level is at in, that is DIN, and further basically you can see coadnssecurity.in, and below that you can see whatever the subdomains are there, dwayth.coadnssecurity.in. So this is how it works out. So for example, if you are looking at facebook.com, you start from, as I said, that the rightmost corner should be the dot, that is root server. Below root server, you have the com domain, and below there is basically the top level domain. And below com, you have Facebook, and below that you have whatever subdomains which you want to look at, www.facebook.com or whatever. So this is basically the structure of the DNS. And similarly, when you are talking about google.com, this looks like this. Okay. Then you start with the root, and below root you have com, and below com you have google.com, and below you have mail.google.com. So this is how it works out. So what does this DNS provide? It is basically a management of the namespace. That is, it creates a hierarchical namespace for referring to resources. Okay. So for example, in a same family, you cannot have two persons with the same name, right? Two siblings with the same name is not possible because the parents will get confused. So similar kind of restrictions are also there. You cannot have same name with meaning two siblings in the same level. Of course, so that's why we need to always have different names here. So consistent hierarchical namespace are there for referring to resources. So what I mean to say is, in this example, say for example, in this example of google.com, I cannot have another domain which says as google.com. It's not possible. So siblings are not possible at the same level. So that is not an issue. So nodes at the same level cannot have same names, and this creates a hierarchical tree structure. And DNS is a very critical component of the internet infrastructure. So we will discuss that in a bit later. And this is a very globally distributed database. Okay, it's not that it is going to be located in few corners of the world. No, it is actually a globally distributed database, very neatly coordinated and distributed database, and a very scalable mechanism. You can have thousands and thousands of subdomains you can add and you can create them. And it is a very reliable database because there is the failure of the DNS server is very rare. And the one incident which happened was way back in 2013 or so, which was that also only partial. It was not even a failure of any of the designed, distributed, scalable, and reliable database. So we will look at what is the structure of the DNS. It is the structure of the DNS provides a decentralized naming system. So what do you mean by a decentralized naming system? In a decentralized naming system, I have the freedom to name. Okay, I have the freedom to name. So for example, what we call is, this is for example, in this coadnssecurity.in, we'll call this as basically a zone. Okay, so below this thing, I can give any name. So for example, I have given Dwayth. I can actually give whatever name, for example, tools.coadnss.in or training.coadnssecurity.in. Any of the names which I am going to create below this is going to be my freedom. Okay, I have the freedom to create these subdomains below this. So that is the point here. So that freedom is basically is what I'm having. This is what we mean to say a decentralized naming system. Okay. So only thing is I can even have a coadnssecurity.coadnssecurity.in, that is possible, but it does not make sense. So only thing is here, if I have created coadnssecurity.in, there cannot be another person who can create with the same name coadnssecurity.in. That is alone is not possible. That is, siblings cannot have the same name. Otherwise, I have the freedom to create any name which I want below the subdomain. That is, I'm owning this domain. I can now create any names that I want below this. Okay, I can say files.coadnssecurity.in, whatever it means. So DNS administration is shared and no manages or administers all the DNS data. So what data of the system available in the world? There is no single entity which is responsible for all these things in the world. So here responsibility is delegated. So for example, root management is done by an organization called IANA, which is under ICANN. So I will not get into that at this point of time because it calls for a separate session by itself. These domains are, these DLD domains are responsible or managed by different DLD operators. As far as IN is concerned, is basically a country level top domain. So NIXI, NIXI, where Mr. Shubham spoke, they are actually managing this particular domain. So they are responsible for it, and whatever comes under them, that they are actually have to ensure uniqueness. Similarly, COIDNSSecurity.in actually is registered with IN. Now, this actually falls under my zone. So now I can create anything with or whatever files or whatever it may be. I can create whatever I would like. So this falls in my freedom or in my line of action. So this particular zone, I am responsible for it. So I can create it, and this will not be. It's not that this data is public, but it's not that they hold. Nixie will not. Tomorrow I can change the IP address for with.coidns to refer to some other IP address, and .in will not bother about it. Okay, so .in will be only concerned about this particular domain name. There is the IP address of this location. Okay, the rest of is falls below because this is falls in my zone. So similarly, the root will be only concerned about this level. It will not be bothered about the further down levels. Okay. So this DNS looks and works like responsible entities is done here. Okay. And let us look at the resolution process, how it happens. So for example, when the client, when I say client, it is basically our browser, whatever we type. So for example, when it calls for COE DNSSecurity.in IP address, it goes to a resolver. Resolver is nothing but a system within the a component of the DNS ecosystem, which finds the IP address for that particular COE DNSSecurity.in and responds. Okay. So the thing here is if there is already a search which has been made for this thing, the data would have been cached and kept. If the data is not available in this particular resolver, it has to go and find out what is the IP address of it. Okay, so it also first reads from the right to left, and first obviously it has to start with the root server. So root server, it goes and says where is .in. Okay, so root server replies that of the IP address of the .in name server. So once it gets the name server which is responsible for serving the .in domains, the DNS resolver will then communicate with the .in name server and ask what is the IP address for COE-DNS-security.in. Okay, so then .in will have a the list of IP addresses or list of the name servers which are serving COE-DNS-security.in. So then it will refer to the name server of COE-DNS-security.in. So then the DNS resolver will communicate with the COE-DNS-security name server. Please remember, I'm not talking about the web. It will basically, this will name servers are nothing but these are entities which will tell which is the correct IP address for this particular domain. That's it. Okay. So this name server tells the name servers basically is going to tell the IP address of here for COE-DNS-security, IP address for COE-DNS-security. Okay. So that would tell. So it tells out the IP address, and then finally the result is passed on back to the browser. So let me discuss once again. The browser, as you type COE-DNS-security.in, it reaches the resolver. Resolver is nothing but a component of the DNS infrastructure or DNS ecosystem, which will find out the address for this particular IP address for this particular domain. So what happens here is it communicates with the first, it actually, as I said, that you need to read the domain name from right to left, and you should always add one dot at the end, and the dot signifies the root name server. Okay, so it communicates with the root name server and asks for the IP address for .in. Okay, because that's the next one. So dot in name IP address for the name server of dot in is given. Okay, please remember that IP address for the dot in name server, not the actual dot in thing. So name server is what? Nothing but the server which will hold the IP address of the given this thing. We call this basically they are authoritative name server we will call, but I will not get into this at this point. So name server are nothing but servers which respond with the IP address, which are authorized to respond with the IP address for a given domain. That's all. Okay, so this will tell the IP address of .in name server, and the DNS resolver further goes next level and then ask for the COI DNS security name .in name server from the .in name server. So .in name server says which is the server which is authorized to answer that it says. So that actually comes as COI DNS security name server. Then the DNS resolver again establishes the connection with the name server of the COI DNS security.in and then gets the actual IP address. Okay, so this is the name server which is authorized and which provides the answer of the actual IP address. Okay, this is the thing. Okay, this particular name server is authorized to provide the answer for the given query. Okay, that is the purpose of the name server. So this is it. So this is the entire process of resolution which happens. So once this resolution of IP address has happened, this will be cached in the DNS system. Okay. This will be cached in the DNS process will not be flown, meaning it will not happen. Just it will, the DNS resolver will retrieve the data from its cache and respond to it. Okay. So this is what happens actually. So technically, protocol, it operates application layer of the internet. It runs over UDP and uses port number 53. Okay. It also uses TCP, but that is only for the authoritative name servers, which actually have to communicate between master and slave. I will not get into this at this point of time. And it's not only whenever we are typing HTTP, this happens. Whenever you are using SMTP, all your emails. Say, for example, you are sending a mail to x.gmail.com or whatever, x@gmail.com or whatever it may be. This actually uses SMTP protocol. So SMTP protocol also have to figure out the name servers. Okay. So any application layer protocol all actually have to figure out the name servers, which is done by the DNS. Okay, so either HTTP or even today we are talking about streaming applications, everything actually need to have access to DNS. So the important thing is if DNS is not able to work, then all these protocols will not be able to resolve to an IP address and therefore will fail. And you need to understand that no single directory exists. Okay, no single global directory which consists of all the data exists at any given point of time, because the data is distributed and every layer and every zone is independent against each other. So this is how it works. So the entire ecosystem of DNS is something like this. Browser, you can actually be accessing the internet or whatever it is, service from your laptop, mobile phones, or whatever it may be. So the browser will try to get the data if it is having it in its cache. Otherwise, it finds out from it connects to your DNS resolver. Okay, it connects to your DNS recursive .8.8, or it can be the one which is being provided by your IS. Of course, you can also connect to any of the open resolvers which are available in the internet. So first, the resolver will try to see if it is having the data in its cache. If it is there, then it will fetch the IP address and give it to it. Otherwise, it will start trying to resolve the IP address for the given domain name. So once how it resolves, so basically it first approaches the root name server. Okay, as I said, you need to start from the right to left. So it starts with the root name server, and then from root name server it goes to the next CCTLD or the TLD like COM or what this thing, generic top level elements it can be, and then after below that it goes to the further domain names, the name servers which serve a particular domain name. Okay, so this is how it works out. So These name servers, which are given for a given particular domain name, can be operated either by yourself or even your DNS service provider, whoever the domain name whom you have purchased from, they also can provide the name servers for you. Both are possible. So this is how it works. And now, any questions?
I think no question is raised by anyone. Only.
Okay, if there is no question, then I have a question for all the people. Okay. So my question is this one. Yeah. Oh, some interesting answers are coming up. No, no, and yes with IP. So that I'm very happy to see that. My answer for this question, for the question in the slide, is yes, but you need to know that address, and photos.google.com might refer to another IP address, and simply google.com will be referring to another IP address. All possibilities are there. So you need to have a wonderful memory to do it. And moreover, today, when you're talking about accessing a web, generally when you're talking today in internet, we are talking about web. So really, we are talking about accessing a lot of files. So of course, it is not a practical solution. So theoretically, yes, but practically, it's not really a possibility to do. Now, my next question for all of you. I gave you the answer also. Okay, so if it has, okay, if the DNS resolver has been poisoned with the wrong entries, then yes, you can actually do that. And for poisoning kind of attacks, you have the DNS sec, okay, where the entries are authorized and put it up. So that is what the DNS sec protocol is about. Of course, because you need to understand that you have the probability of getting wrong answers if DNS sec is not implemented. Okay, so now my next question. What is the answer for this? If DNS is not poisoned, then how do I land up in fake web pages? Sometimes I land up in fake web pages. Okay, spelling mistakes, phishing redirections, defacing of websites. Okay, phishing websites. Okay, great. So that's the right answer. Okay, great. So here you are seeing, this is a very famous one. Actually, the bank also had told that such kind of thing is not being sent by them. So people, it has been told that not to fall prey for this kind of things. So here it takes about the bank, which kind of wants the account holder saying that their documents has been expired and they need to reach this particular URL and to otherwise to unblock their account and things like that. So people wrongly get, meaning they wrongly click on this, and then of course domain squatting is also another thing. There are many things, but this is basically a tricky thing. So you fall prey for it, which a normal end user who is not aware of the technicalities will actually think that okay, the bank's name also is there in the domain name. Okay, so that's why I told you that you should always read the domain name from the right, from the right to basically from the right hand side to the left hand side. So a normal user will get will not be suspicious enough, and he might click on and then probably end up providing his internet credentials and things like that. So it is always important to look into that. And one of the most fundamental things that you can do is look the domain names from the right to left. And second thing is basically not to click on links. As much as possible, try to type it in the browser. Only thing is nowadays Google does not allow you to complete it. It finishes, the browsers also finishes trying to do it. But okay, in the represents the country level top level domain, and then this SBI update KYC is here. Okay, so here this looks like a subdomain of straightaway under the in. Okay, if you look at that particular bank's website, they have their own this thing, their own top level domain. They actually did not even in also. Basically, generally it would be SBI .SBI is also there and things like that. So here, basically, this is looks like a meaning, though it sounds very genuine, HTTPS and things like that, it is really a fake website. Okay, if you are a customer of that particular bank, you'll be knowing that their how their it will basically SBI.com or SBI.co.in. This is how you'll be knowing it. And of course, these days, in the past 6 months or so, they have their own new generic TLDs, GTLD, which is actually .SBI. Basically, that's what they have as a very top level domain. So that is also there. So, but here in this case, this seems to be totally a different website, which is having absolutely, once you should see this kind of things, you should getting suspicious. Okay, the brand is somewhere here. Okay, the brand name is basically somewhere. No, this is not called hacking. This is basically a kind of what we can say is you are being tricked, basically phishing, or basically kind of basically phishing, or basically you are being tricked to fall into the trap. Okay, so this is the thing. And both these categories, okay, whether the DNS giving a wrong answers or the DNS being misused to basically, this is a this thing, the DNS infrastructure is misused for abusive purposes. Then we call the both. So that's it. So any questions are here?